Hi, everyone. My name's Jack. I am going to be talking tonight about type-safe APIs. Hopefully that sounds at least vaguely sensical to you, and otherwise I'll do my best to make it sound appealing. It's something that we've done we've tried to make happen at Politico for the last year or so, and I think we've struggled through parts of it, and then we've gotten a lot of benefit out of it as well. And it's something that I thought a lot about in my previous role, where we tried and failed and wasted a lot of time because we were missing exactly this. And so yeah, we're gonna talk through it. All the client or front end code samples that we'll be going through, kind of most of the second half, will be Vue, but we'll also talk a little bit about what this means for your backends. And I have a couple questions to try to get a feel for how people are currently interacting with their data or with their backends. So this is me, front end at Politico. I like Vue and TypeScript, and I've talked about shared components, but a lot of really like front end DevOpsy type stuff. So that's kind of where this talk came from. Let me go ahead and real quick, I'll share afterwards. So the slides will be posted afterwards. The two relevant repos will be posted afterward. So don't worry too much about detailed notes. So we're going to go through three rough parts. One is the background of why something like this might be necessary for you or for your team. Then we'll talk about what I think is one proposed solution for how to handle this issue of how do you communicate consistently and safely and in a maintainable way between your backend and your front end. And then we'll do the second half or so will just be code demos. It'll be a lot of live coding. I've done most of this already once, and it mostly works. Live coding, maybe it'll work. So a few polls. Let's start with who here, so presumably if you're here, you're at least interested in front end in some way. Maybe you've worked with Vue a little bit, maybe you've worked with it a lot. But on the other end of the spectrum, who here in your current role or in previous roles has worked with apps that are rendered on the server? So, yep, cool, we've got half or so. So that could be something like Ruby on Rails or .NET, maybe Laravel, or if it's Java, it's Spring Boot. But that's where I would say for a fairly long time, was the standard, because you could only do so much in the browser. And so that meant all your data modification and accessing was right next to where you were rendering, both often file-wise and like in terms of your repository, which for a variety of reasons was both good and bad. But it did mean that you were pretty confident that when you were making a change to how you were getting your data, you could quite easily also make the same change for how you were displaying it. Who here is now working with single-page applications in some way? Cool, nice. So yeah, this is now that we can do a lot of code or execute a lot of code in the browser. Obviously, the reason we're here at a Vue meetup is because single-page applications, where you are calling something else to get your data and then doing everything about manipulating that data and displaying it in a certain way, that happens entirely separate on the front end. And then who here, I guess I'm mostly asking about once you've been working with the single page application, has at some point been frustrated by how do you maintain your data in one place in your backend, and how do you know about those changes or consistently handle changes or know what you should be doing when your backend makes changes? Who's had some level of that frustration at some point? Okay, cool. That was the key question, because if no one raised their hand, then I'd just walk out and we'd all get to go home early.
GraphQL Apollo.
Yeah. A couple more quick questions. This may not lend itself super well to a poll, but quick show of hands. Are you accessing some or most of your data from an API where you make an HTTP request?
GraphQL, yeah.
Yeah, GraphQL. Do you know, does anyone know how those APIs are documented, if at all? So, yeah. Nice. Swagger? Anyone else using Swagger? Cool. Anyone else aware of any other specifications? Obviously, GraphQL being one.
Self-documenting, right?
And then this is sort of a rhetorical question, but what happens when those backend APIs change, and how do you handle those changes, and how are you made aware of them? Cool. So let's. We talked briefly about this in the beginning, and I talked I was there for at the beginning. I mostly this is something that you just talk about when you talk about single page applications, because you want to make sure that you're we'd like to make sure we're not just repeating other patterns, and that there's a reason we're making our changes, and the reason that or we want to make sure we're just not repeating other mistakes. The reason that things are quote unquote different now than whatever 10 or 20 years ago, and why new patterns might be useful, is because with more processing power in a browser, you can run most of your application there. You can store a lot of data, or manipulate a lot of data, or do a lot of animations, or compute a lot of things. And so by being able to load and use a decent amount of JavaScript in the browser, that implies something different about how you'll structure and how you'll architect your code, and where business logic lives. So previously, you would do your data fetching, modification, and rendering. You would all do it in the same place for your Rails or .NET or Laravel application. And that meant that they were quite literally right next to each other. And so it would be tough for those things to get out of sync. Then some things happened. And so now our rendering with whether it's React or Angular or Vue or what are the other ones? Ember, Elm. You are Svelte. That's the hip one right now. Your code for rendering now lives totally separate from the code for fetching or modifying your data. This is really convenient in a lot of cases for team breakdowns. Who here would describe your role as front end, where other people on your team or at your company have a back end role, and you sort of work separately from them? Is that the case for at least some people? Cool. Whereas perhaps if you were just working in a .NET application, or perhaps if you were just in a Rails application, those would blend a lot more, because everyone would be literally touching the same files. Now you can very easily go an entire project, and I have, where I don't touch Java code at all, and someone from the backend team will not touch the Vue code at all, which is great because you can work separately so long as you're communicating. But then that begs this last question, which is sort of what we're talking about tonight, which is how do you make sure you're communicating, and in sort of a idealized workflow or process, can you remove as much communication as possible while still being safe with your changes, so that the back end and the front end can stay in sync without constantly having to ask, hey, are you going to change that thing? Or I already changed that thing. Is it ready to go? That kind of stuff. So this is tenuously related, but I really like XKCD stuff. I also, it's a little tricky to read. It's a totally separate thing, but it basically represents monolith versus microservice stuff. So we'll start arbitrarily here. This technology makes it easy to create arbitrary connections and integrate everything. So that would be perhaps in this analogy, there's a monolith where it's great for everything to be able to live together so that you can change anything that you want. This diagram is focused on security, but now that everything's connected, we can't keep track of, we can't make independent changes. It gets to be a slog. If you want to change one thing, you have to make sure that you're changing everything. So then what if we separate things out? So that I can make changes to my microservice and you can make changes to yours, and we don't have to worry about how they affect each other. But oh no, I wish they could communicate more easily, because now how do we keep track? So in this imperfect analogy, we'll call this a server-side monolith where all your code lives together. We'll call this a single-page application with microservices. And given that those are both scary red areas, the talk today is sort of like, how can we best, given that we have the benefits of a single page application, but we're getting frustrated by wishing that they could communicate more easily, or at least stay in sync, kind of what can we do in this area to make it easy to connect or keep things in sync? So we're looking for ways to keep them together, keep them in sync. reduce code duplication. So this was probably the major frustration at my previous role, was that they were previously a full .NET shop, I guess you would call it. So they had .NET applications where it was all server rendered. They switched over to Angular, the TypeScript Angular. And so now their code is separated in a generally nice way, but it meant that because there was no way to share information about types from the backend to the Angular code, it meant that every time we changed something about the customer object, for example, you changed it in at least 2 and usually 3 places. You changed it in the database model, expected, then you changed it in the the C# model of that entity, also probably expected, but then you had to go over to TypeScript after you had made this exact same change from first name to just name, and you had to go remember to do that in TypeScript. Otherwise, it might break silently because you're in this analogy, the HTTP call is sort of like a bridge where there's no communication and you're just kind of crossing your fingers that things are going to go across that bridge in the way that you expected them to, or the way that they did 3 months ago. So you want to reduce those, not just duplication in the sense of like we want things to be dry without repeating ourselves, but it'll also just be quicker if we only have to make the change in one place. So we're getting very close to the end of the slides, which will be good because lots of code. So the thing that we would propose here that has worked well for us at Politico is to share types and information about APIs and their endpoints using code generation from API specifications. Theoretically, you could, it would be tricky to imagine how this would work. But theoretically, if you just want to share information about types, you could perhaps define TypeScript interfaces and somehow generate Java or C# classes about those. But something about that feels a little bit wrong, especially since backend is closer to the data models. So I think this is a logical approach, which is backend has defined these types. We'd really like to not have to go duplicate them ourselves. How can we approach this? So some of the specifications that we mentioned, OpenAPI being the most current, but it's just a descendant of Swagger, which a couple people mentioned. There's also a API specification called Blueprint, and there's one called RAML, but they all do the same thing. And to explain, let's take a quick look at one of them. So probably could have had this open, I guess. Here is one simple example of what this could look like. How's that for size? A little more? Good? Oops, it's gonna have to be. Where a specification file in this case is just a large JSON object that describes the API and what goes into it. In this case, this Oxford API has a license. It has things about origin and headers that need to be applied. And then it has things for security definitions. And finally, it has paths, which are your endpoints. And so you can have, to any degree of detail that you want, regardless of whether we were going to attempt to do something extra with this information. It's already something that a lot, maybe even most backend teams are doing, because it's useful to have a standardized way to talk about your API, and it allows you to use other tools involved with generating code for that API, or having a UI where you can see this is the way I expect the API to behave. And so we stumbled into this a little bit at Politico because our backend is in Java, and Spring Boot in most cases will just automatically start with Swagger as long as you put in sort of the minimal effort to enable your API specification. And then going forward, it's pretty straightforward. It's a little bit of extra annotations, and we're going to take a look at some examples. But I think the thing to impress upon people here is that this large, crazy-looking, here, let's see it in crazy-looking big files, lots of text, is in most cases for most backend teams something that they're already generating because it's useful for those teams. to interact with their own APIs. And our goal tonight is to take advantage of that. And or if you're in a situation where you don't yet have this available, to point out how it might be feasible to encourage your backend team or work with your backend team to attempt to implement this. So OpenAPI, it's an API specification, describes the endpoints, the parameters for for a get or a post, and very importantly, it describes the responses that you'll get. So if you are going to make a request to create a new user and you're going to get back a user object, you don't have to worry about trying to go make this call a few times in your browser to see what the responses typically look like. And instead, you can just know that the API specification has described that a user will have an ID, and they'll have an email, and they'll have a profile photo, and you can be confident in that. And so we're particularly interested in what we can do with generating our HTTP clients, ways to access the API. Most of this we've talked about. Backend code, we're going to try to make our source of truth. We will use that specification to generate an HTTP client. And tonight we're focusing on TypeScript. Here's another poll question. Whether in Vue or in any of your code, who's using TypeScript or has used TypeScript? Cool. Who would like to use TypeScript? Nice. The great news here is whether or not you can or want to, you can generate this code, and it's quite easy to then just use the JavaScript version of it while still having the TypeScript annotations. So I don't know, one more, there will be more polls. This is not the last poll. Who uses VS Code? Cool. You'll notice the really nice behavior about VS Code basically knowing what you're typing is because so many packages now have TypeScript definitions saying this is what this code will do, even if they're actually shipping JavaScript code. So you can do the same thing here. It's quite straightforward. So you don't have to, the takeaway here, especially if you're using VS Code, there's no reason to have to use TypeScript in order for this process to still be quite beneficial. And then our clients, the goal will be to reference this single source of truth. Some resources, mostly this is just if you want to take a look at the slides later and know where to look. We're going to be focusing mostly on OpenAPI and Swagger, but know that this idea can work with Blueprint or with RAML, and Tracy gave, people have already given excellent talks about GraphQL. The idea of using generated code or generated types is also quite applicable with GraphQL, which is also a self-documenting thing in that you can use the GraphQL schemas to get TypeScript interfaces, for example. All right, that's about it for slides. So we're going to start to jump into code, and hopefully to give a better idea of what this looks like, and most importantly, what the benefits look like. Any questions so far? Cool. We'll give it a shot.
Good luck, Jack.
Thanks, Chris.
Did you do something to his demo code? No. I'm just wishing him good luck. It's positive.
I appreciate it.
I thought I could practice some sarcasm there. Me too. No sarcasm.
All right, so let's start with the thing that, at least when we started the presentation, was working. And then we'll try to refresh and see if it's still one. We may have to come back to that one. What we have here is just the front end of an app that I put together. It should look quite familiar because this is basically the Vue default app, sort of modified as little as we needed to give a couple different examples of how this works. So we have a home page. We have we have a page for New York Times movie reviews, and we also have this custom candidate API. Feels topical. And or it was just the first thing that came to mind. I shouldn't say none of this is real data. It was real data as of yesterday when I copied and pasted it into a sample database. But it's just to give us a chance to interact with an API that we control. So for those interested, we will, again, these will go out after the talk. We're going to be talking about two different repositories today. One is the Vue app here, which will look quite familiar. And then the second is a Java Spring app. We don't need to get too bogged down in the Java specificness of it. It's just, it happens to be what our backend team uses at work. And so I know that it will be fairly manageable for documenting the APIs in Swagger. But we'll take a little bit of look at the Java code to see what it means to add annotations, and hopefully to give a little bit of ammunition if you're in the position of needing to convince your team that this is something worth doing. All right, so here we are in the Vue app. I'm going to go ahead and run it. Pretty standard stuff of an app, some routes, and we're going to start off with the movies component. Is this large enough for most? Cool. So the movies component is what we're using right now to render the New York Times movie reviews, and a very solid resource, especially in preparing this talk and in sort of experimenting with what exists out there, is this Any API application, which itself references API's guru. Man, it's tough to do this. What was that?
I saw GraphQL, whatever you looked at.
Oh yeah, we create tools to help developers work with GraphQL and OpenAPI Swagger. They're both possible. And so we have, let's see if I can find, I think this is what I'm thinking of. Yeah, I think this is what so this is sort of the central repository of public-facing APIs that have been documented in this OpenAPI specification. And so there's a maintenance here of many APIs, many APIs, which is what this Any API UI is helping us access. But what's really helpful is you can see what big companies and small companies are doing in terms of their documentation. And it's pretty straightforward. So I scrolled through a few of these, and Times Movies was the one that I ended up being interested in. Oops. Let's try movies, see what we get here. Yeah, movie reviews. So they don't, in Any API, they're not broadcasting that this all comes down to one specification file, but you can find it pretty easily. It's this request right here, and it's that same large JSON file that we looked at previously. So if I take a look here. Here is the New York Times movie review specification. So in order to access this, if I wanted to, because they tell us here, for example, like.
Can you make that bigger?
Yes, of course. Sorry, that's a mistake for sure. So they're telling you things about their endpoints. So they have this reviews search JSON is one of their endpoints. If we were to have people here used Axios, I don't know if that's a common thing for most. So normally, in order to get this data, we would use Axios and we would write out the URL, and then we would manually, annotate or concatenate a string if we needed to pass in parameters, and then we would hope that we get the response that we're expecting, and then we would sort of guess our way through what is the shape of the response and sort of. Best of luck if it changes. Now we can instead, in this file that I've put here in build, we can say, I want to generate something based on this specification file. So all this is a link to that JSON file. So New York Times movie reviews, OpenAPI.json. And the request or the command is this OpenAPIGenerator. So that's linked in the slides. It's one of the important tools for this process. And what OpenAPIGenerator does is it takes in the spec file. You tell it where you want to output the code that it's going to generate. you tell it the way you want to generate the code. And this project is sprawling. There are clients for Python and Kotlin and Java and the other ones. And there are multiple TypeScript clients. There's one for Angular. There's one for, I think there's one for AngularJS. There's one for Axios, which is probably going to feel the most familiar to a lot of us. But they give you lots of ways to choose to consume this client that they're going to generate. And then you can pass in some additional variables if you want. So to show this in action, hopefully, let's go ahead and delete these two, which were previously created. Our command is just based on, based on what lives over in package.json. So I just have it as generate API clients. So that's going to go through and it's going to find, right now it's just two of them. It's going to generate a client for this candidate API, which we'll get to. That's our custom created one. And then it's going to generate an API client for Times Movies. And now we have these folders again, and this is what they look like. Just a lot of generated code. They emphasize in each of the files that this is generated, don't try to change it. And it looks like this. It's really, really well-documented TypeScript. Depending on whether or not you've worked much with TypeScript, this may look familiar or may look weird. But this, for example, is just JS doc to help you get additional information about the types that you're receiving. So we now have our generated API files, and it's time to use them. So now I'm in Movies. I guess I can show real quick. This is my key, if you can memorize it. And you can use it to your heart's content until they lock us out of the movie API, and then we'll create a new account. So to get started with using these, they're just classes that you initialize. In the case of Times Movie API, it has authorization associated with it, which is just you go to developer.nytimes.com, you give them an email to authenticate, and they'll give you a client key. So obviously in APIs, you don't want anyone to be able to do anything they want with your API. In my case, the one I've created, you can do that, but it's hosted on Heroku, so it'll like go to crap pretty quick. So we're passing in the API key at the time that we initialize it, and that's what's going to allow us to be properly authorized when we make our requests. Cool. So that's initializing the API. Any questions so far? Okay. Now we get to start seeing the magic. And for people who are already doing things like this, A, I hope you love it. I really love it. I think it's so much fun. And B, sorry if any of this is redundant. So here in Movies, when our component is created, we're going to perform a search. And performing search is just setting loading, and then then this is sort of this is what we've been building up to. So we have, and let me go ahead and redo this. So we're going to set our reviews response. So we're going to await Times Movie API, and then the beauty of TypeScript, I'll type my dot, and I get to see all the endpoints that exist on this API that New York Times is maintaining. And the one that I'm interested right now is to search for reviews. So I can go ahead and select that one. And then I get this wonderful, wonderful thing describing exactly what New York Times wants me to know about using their API. If I want to pass in a query, that's the first parameter. If I want to only target movie reviews that are critics' picks, I can do that as well. I can get additional information here in JS doc about what exactly it means to pass in a query. I can sort by reviewers or by opening date, and basically see exactly what the New York Times API developers want me to see. And you can very quickly imagine that for real world or for profit APIs, you get to see exactly what your backend developers have already been explaining to each other at the time that you're in a totally separate code base. Okay, so I will pass in my keyword, and that's about it for now. I'm really only interested in the keyword at this point. Cool. So and then what do I do once I've made this request and I want to know what I should be doing with my data. Then I'm going to, I have a movies defined on my component, so this.movies. And movies, I've said, needs to be of type. Please, if I'm going too quickly with any of the TypeScript stuff and any of this throws you off a little bit, please just stop me, and I'm very happy to dig more into it. So when I set up movies initially, I gave it a type of movie, which at my previous role, that would have been something that we defined in Angular after they had already defined it in C#, after they had already defined it to initialize the database. But here, movies actually just comes from times movies. So a beautiful VS Code thing. Let's F12 into that, which should just go to definition. So I can see exactly what interface was provided by the New York Times to create a movie object. So it has a byline, it has information about critics' picks, it has display title, it has headline. And so I know that I can set this movies equal to my response dot, and I get to see everything on response. And then I get to see everything on data, which is what the Times has defined. And I can see that results, and this may be a little dark, but results is itself an array of movies. So that's exactly what I want. Cool. This is going to yell at me because it wants to make sure that this is not undefined. And moment of truth. This says 3.7.2. Does anyone know what I'm about to do right here? Oh, it's so beautiful. What? Oh, someone said it? What did you say? Yeah, optional chaining.
Okay, we have to talk because
it works.
Oh, you know what? You have to be on the latest version.
You need
Webpack 4.
Maybe.
Whatever, right?
You need TypeScript 3.7 is where this came out.
Oh, yeah, okay, I'm gonna talk.
So this is something that has been we've been talking about for a while. It's a way to access potentially undefined things, and it's super useful, especially in APIs. We'll see it in a couple other places in this project. So now TypeScript / VS Code knows that results is going to be an array of movies or undefined, and if it's undefined, we'll just do an empty array. Movies is appropriately set, and so then as the pop quiz just view portion, I have an array of movies. What should I do in my template to display those? Yeah. And in Vue, we'll probably do it with a v4. So here we are down here. We're going to do a for movie in movies, and then this. Has anyone used in Vue / VS Code? Viter has an option. It's experimental. It says I think it's template interpolation service is I think what it's called. Has anyone played around with this? It's also wonderful. So it's a setting. Just set it here. Template interpolation service. You turn it to true. Right now it's by default off. But what that means is that, and it's incredible. Previously, Vue had no idea what your template was doing in relation to your script. In a single file component, there's obviously a lot that goes into correctly parsing the 3 parts of your component so that they can be displayed in your editor properly and then bundled to the browser properly. And previously, you just kind of had to accept that once you were in the template, you kind of lost all information about what lived in your script. But with this wonderfully functional ability here, which this is checked into the repo, so please definitely feel free to grab it, you will get yelled at if you're doing things that are not TypeScript allowable. You'll even get wonderful TypeScript error messages, like property link does not exist on type movie. Did you mean link? Absolutely, I did. So it's 2 or 3 things coming together there that takes you from basically no type safety when calling APIs because you're just hoping that things haven't changed, to having type safety when calling the API. You now know exactly what parameters are required and what types they need to be, to having type safety when you get the response from the API because they're telling you this is the set of objects or arrays that you're going to get back. And now with the Viter update, you can even have that same type safety just using the generated classes in your template. which is awesome. So same thing here. If I were to do display title, it'll yell at me. If I were to do something other than movie, it'll yell at me, which is really, really quite great. That's essentially what's going on with the movies component. Let's make sure it still runs. We'll take a look at how it's functioning. The other parts of this are mostly just handling search. When you perform an action in the input, it'll send that keyword to the Times API. So let's take a look at this. Cool. So we're getting our initial response with an empty search result. Anyone have a movie?
Avatar.
What was that?
Avatar.
Woohoo! With Avatar, James Cameron has turned one man's dream of the movies into a trippy joyride about the end of life as we know it. Compelling stuff. So the thing that got generated just by me passing in a keyword looks like this. The header is to the New York Times. It's going to the reviews route. It's applying my API key. Again, if you can memorize this, definitely do it. And then it's applying the query that we just typed into the search bar. And we get a response that matches exactly what the Times generated code has told us is going to be, which is just an array of movies. Something that's sort of related here, or sort of interesting, is that I have no idea how the Times, in this case, developed their API. It could have been Java, it could have been Python, it was probably Go, I don't know. And it doesn't matter because we, as a developer community, have agreed that this API specification can work for any type of API, however it's developed, and we can all agree on how it's going to be described, regardless of how it's originally developed. Cool. One more movie. Anyone?
Star Wars.
Nice. So this should be a few, one would imagine. Nice. Now I really wish I had a reviews type thing, because I think they have information, and that would probably be fun. Do they have? Right now, no, but you can. Critics pick. I don't know if they have anything about. I don't know if they have anything about like stars or thumbs up. But these links do work. It'll take you to the New York Times. So that's our external API that we're playing with, sort of to see how it works and how we can generate easy clients to access, have type safety. Any questions about that? Yeah. Oh, sorry. What was that?
The class you auto-generated. I noticed when passing the API keys. Are any other statements inside of that class, like last error?
Yeah. From what I can tell, it's only things that you would pass at initialization. Okay. And it's almost always related to either the base URL or some base headers that you want to apply, or things related to authorization, which are sometimes the same thing. For the most part, it's not something where you're adding to or adjusting the statefulness of that later. One thing that is nice, for example, for OAuth, I think, is where this is most useful. But all the authorization approaches that they have built in will accept both a value and a function. So if you have to wait for something to be ready, you can also pass in a function at the time you initialize the API, and that'll run when you make your call rather than just when it is first initialized. And sorry, what was that, Brian? The request?
Yeah.
So this is just a get. So it's just query like that with an API with an API key like this.
Is v2 literally in the URL? That's the only way you're specifying the version of it?
Yeah, it is that when I generated the API, v2 was the one that was pointed at. So here we are here, 2.0. And so 2.0 describes it here, and it if we were to take a look at this spec, and I will zoom in here, I think it's just this type of stuff. Yes. So this is, and I'm going to be fully honest here. It's a little tough for me, or at least I haven't had to worry about the difference so far. Swagger was the original name of this, and it was very similar. So there's Swagger 2.0 is the most recent Swagger named specification for APIs. And then in an effort to move this type of specification away from one company, Swagger being the open sourced but product of one company, there was agreement on an OpenAPI specification, which is OpenAPI 3.0. For this generator tool, it doesn't matter which. It'll work for both. I haven't yet, and it's been a year or so. You could eventually run into a more esoteric case where those differences matter, but so far that hasn't been the case. All right. Oh yeah, sorry.
I guess, does this really only work if your data structures are like really, really good?
Yes and no. Certainly the most benefit. Yeah, no, it's a fantastic question. If you have just a set of endpoints that already exist, there's a pretty significant benefit, I think, to being able to track just those, where it's not at all about. It doesn't need to be about, for example, the response types. Those can default to any, for example. But tracking the parameters that you need to pass in, or what the URL routes need to be, and initializing these APIs, perhaps for a specific environment, and to be able to track all the places that you're using each case of your API calls with easy like VS Code navigation between types. I think there's a pretty significant benefit, even if you were to have to annotate all of your response types as any, and sort of skip that part. But obviously, a large benefit is once you have good enough data structures that, if for example, if your API is in Java or C# in particular, those essentially have to be already annotated for return types, just because those are strongly typed languages. And so you don't need to worry about how good those structures are. They'll still work and be accurate. For loosely typed backend languages, probably more effort to then document those things, whereas it's pretty automatic with strongly typed backend languages. Does that make sense? Okay. Happy to dive back into that if it's useful. Okay, so that was our public API that we were looking at, and now we want to see what this workflow could feel like if you were working with someone maybe across the building, but still at your company, who's working on the backend API that you're consuming. So this is going to come from our candidate API, and this here is a similar Swagger definition or OpenAPI definition, but this is a Spring Boot app that I put together that just lives on Heroku. And this is sort of the unknown part of the demonstration, because I learned just over the past couple days that free Heroku instances are great, but they'll also go down for 20 minutes at a time and without much warning. So here I have a pretty basic API, and something that we haven't even looked at quite yet is that for things that use Swagger, it's quite easy to use one of the built-in APIs, one of the built-in UIs handling this type of definition. So here we have Swagger UI for this application, and we can see that it has some error stuff, and then the few endpoints that I created here about candidates. So we have an option to get all candidates, we have an option to delete a specific one, to add one, or to search for candidates by last name. Let's jump into some of the code for this. So this is obviously not the focus of the talk, but we want to see what it actually takes for your backend team to add these annotations. We have a very basic Swagger config file, which just says, I want to use Swagger in this application. And then we have a candidate file, which is about defining the object that eventually is going to end up in our generated TypeScript files, which we're going to use on the front end. And obviously, in the same way that we have no idea how New York Times wrote their API, for our front end developers, you're eventually not going to have to care about this at all, because you're just going to be interested in what it generates. It's just a class which has some properties on it, and then in this case, Spring Boot, which is the Java framework, is responsible for doing some things where it annotates properties so that they can be properly read for your API specification. Then we have a controller, which is responsible for actually doing things to the data or getting things. And this is where we have a few things that are used to help create the specification file. We have in Java, you have things like API operation, where you're naming the operation that's going to be the name that's going to be referenced by consuming apps. You have to say, the method that it's going to be, and then you just perform whatever functions you're interested in here. Here, it's just finding all the candidates and returning them as collections. So your question about data structures, because Java is strongly typed, I don't have to do anything here about annotating. When you call get candidates, these are the properties that are going to be on the response that you're getting, because in this case, Spring Boot is responsible for saying, if it's a collection of candidates, that means in TypeScript it's going to be an array, and each of those candidates is going to have these properties. So it's certainly for the backend team that you may or may not be interested in convincing to work with you on this, it's certainly a much lower lift for them if they're already using a strongly typed language. Cool. We're going to have to do this eventually because I want to demo what it's like when changes happen. So let's go ahead and, have I dug myself my first hole? I wanted to.
Not a proper talk.
This relies on environment variables that I previously had in terminal that are probably no longer there. I'm gonna go out on a limb and
Just try history and see if you can.
I don't even know. Let's
Remember a name of one?
what?
Do you remember a name or part of the name of one?
I do, yeah.
So I
Go
should
back
just do
there.
yeah.
Oh boy. Well, hold on. Let me grab the name of it. Okay. Now what?
That's how it would have been typed in. Right?
Yeah.
You Control R,
Control R.
paste, and then you can keep Control R and continue that.
Oh, interesting. Okay.
You're out of it. There you go.
Okay. Oops. Oh.
Yeah, now you're searching something else.
Okay. How do I? It's I may escape.
Or Control C or any of those.
Okay. All right. Let's try it. Wait. Let's try this one more time.
Control R.
Control R.
Right. See,
Paste.
you see reverse search. Now you know you're in it.
And just
then you paste. Now you can start flipping through it.
with up down. Control R.
Control R.
History's just easier.
All right. You know what? We're gonna leave it because we can still see this when it goes to Heroku. So we're just gonna cross our fingers here. So let's take a look at where we're using this, where we're using candidate. So we have candidate.view. In the same way that we were importing the Times API previously, now we're importing candidate API. And we get this same really nice generated code here. So we're going to go into candidate controller. This is all just, the F12ing go to definition with VS Code. And we'll see, here's the add candidate method. Here's delete candidate. On add candidate, we can see things. For example, if we jump in here, we can see things about the return type. So it's going to be a promise with a candidate return. And for the most part, we don't need to worry about this because it's just going to happen when we execute that code. So let's go. Oops. Cool. So when, in the same way that we made an initial request for our New York Times search, when candidate loads, we're going to get candidates. And that looks, we won't spend too much time on this, but it's the same kind of thing, right? So const candidates response equals, so we're going to await. We're going to use the candidate API, and we're going to do get candidates. So we see all of the methods that have been made available by this Java API. And then that means that when we have the response, we can see that data is going to be exactly the type that we're interested in. It's just an array of candidates. Same thing with the great Viter interpolation. We're doing a v4 here, and if I think that it's just a name property, it's going to yell at me, and it's going to tell me that's not an option. Let's go with first name. Cool. Let's take a look at where this is running. Woo! So these are, in the Spring app, they're just the default values for the database. But the database that it's calling right now is on Heroku. Here we are. So it's calling this Heroku app and getting the candidates. Remember, we never had to type out anything about the base URL because that was included when we generated from the specification, and we never had to type out anything about the name of this endpoint. And when we were typing things to display these cards, we got the type safety of knowing that VS Code would yell at us if we got it wrong. We can also, we have this add candidate component. So let's take a look at that real quick. Add candidate is all about fields and submitting something, but we get the same really nice sense of confidence, essentially, that not only are we doing the right thing for the API right now, but if the API changes, which is hopefully what we're going to demo, and that may be the thing that falls apart, but we'll see. If anything ever changes, we will find out about that because we're not referencing some standalone model that we created only for the front end. We're referencing this candidate model that is generated and has the things that the backend has told us will be there. And so in add candidate, if I were to say that the model for election cycle, or even better, how about for party, if I wanted the Green Party to be an option, I would know that the backend is not set up to accept that right now because it's not a valid part of this enum, which is a TypeScript specific concept. If they added Green Party in the future, then I would know about it as soon as I updated the API that I was consuming. Cool. And let's see if this is still working. Candidate preferences, Democrat, Republican. Nice. He's not on here yet. Great point. 2020. And I don't know what he was at, but I think he was like 4.5 or something.
Yeah, he's like 4.5.
All right. There we go. He shows up. And this is Heroku. It's just a Postgres, so it's there. It's saved. We could also say that these two guys probably aren't going to be around a lot longer. So, yeah. And like, what if he wasn't around? And those are real deletes that are happening right now. So that's what exists in the Postgres database. Cool. So we've proven this situation of it's an API. We're getting information. We're updating information. Very importantly, if I were to say that I thought instead of election year, it was just called cycle, for example, and that was the thing that I was going to try to pass to the API, it would yell at me because it knows the API is not set up for that. But I think the last use case that we'll try to cover here and just see if it breaks, I guess, is that lots of times you will be making changes or something that we've had come up 3 or 4 times just in the past couple months is that in a microservices architecture, remember the diagram, pretend it's there. you have lots of things going on at the same time, and often it's nice to be able to develop totally independently. But you'll reach a point then where you realize, ooh, all three of these services are describing the same thing. And for example, I'm saving a person. I'm saving it in one microservice, but it needs to be accessed in another one, and it needs to be edited in a third microservice. And they were developed independently, and they developed very similarly, but 2 or 3 properties are off, and that means we have to do all this mutating and mapping, and that becomes really frustrating. And so 3 or 4 times in the past few months, we've worked with our backend team to say, let's standardize those. The Java team is going to take the time to figure out which properties are shared. They're going to share this class. And then we know, because all 4 or 5 of our Vue applications that are interested in these microservices, because they're all using TypeScript and they're referencing these generated 6 API clients, we can be very confident that we're going to catch the places that need to be changed, which is a really satisfying and useful thing, and for us, I think, has sped up development time. So let's say in this case, the thing that got changed is that election year. And I'm going to cheat a little bit here in the code base by just making sure I catch the things I'm expecting to. Let's say that election year, this is when we're getting a candidate, but in the places where people are saving candidates to their account, like it's someone that they want to follow, when that was originally created, it was called cycle. So, cool. So in those cases, So now the backend wants to make that change so that things can be more consistent. We're going to add this. Fix, make naming of candidate props consistent. So this is theoretically a change that the backend person on your team would have made. They're going to push it. And then they're going to, and if we have time, which I think we'll have a little bit of time, I'll talk about the one level of CI that you can add on top of this. But imagine for now that the thing that they're doing is their changes are getting deployed, right? Their changes, in this case, they're going to Heroku, but maybe it's to your dev environment or something like that. In some way, those changes are getting are deploying to an environment that eventually is going to affect your front-end code. So that's what's happening right now. And what we know is that if we made no changes to our code, it would break, because we're expecting it to be election year. And at best, it'll not display. And at worst, no one's going to be able to save a new candidate until we fix this. And I think that's been a huge thing for us as a team, and sort of that front-end DevOps approach is, how can we catch things earlier? Obviously, testing is a huge part of that, but I think TypeScript has been really good for us in that the goal being, instead of catching something while you're running the application and like peering through network logs or console logs, can you catch it before your build even deploys? Because TypeScript, obviously, all of its benefits happen at build time. Okay, so if things worked, that deployed to Heroku. So let's take a look at, it got bigger. So we're going to see if the model for this has been updated. Yay, it has. All right, so we have an updated deployment on Heroku, but that means if we make our request right now, and actually let's give that a shot, I would expect that there may be issues. So here we are. Let's try the actual deployment if I can find it. Here we go. All right, so home should still work. Cool. New York Times should still work, but this should either fail or hopefully, if we're handling things correctly, should just not display election year. But then we would also expect that when we try to save a new person, it probably won't work. Okay, there may have been a chance that I wasn't displaying election year anyway, which obviously that's, oops. Okay, no display of election year. But if we save someone, let's see what happens here. Oh, and see if we got it back. Where are you? There we go. All right, cool. So even though we had 2020 selected as our election cycle, which is what we were hoping to be applied, it's no longer going to work. And now every time we get this person, it won't exist because the APIs were not correctly set up. So normally, if this was a normal sort of JavaScripty workflow, that would just be the case until someone in QA notices it. Or if you're like me and you weren't displaying it in the UI that you were interested in, maybe you never notice it until it is much further down the road and becomes a problem. In a TypeScript workflow, the next time you'll notice it, hopefully, is the next time you get your latest API clients. So we're going to run this. Remember that it's generating against the specification that's deployed on Heroku. Cool. So it generated. Now, imagine this is running on CI. You've just updated your clients, and you're expecting everything to be good. And I think this should fail. If this doesn't fail, then that will be sad. Yeah. We get a useful message. Object literal may only specify known properties, and election year does not exist in type candidate. And there we have it. This is what we would get as a message on CI as soon as the backend person has made their change and we've attempted to use it. Either that be locally or it'd be while the front end build is running. And we know that in order for our app to work without even running it in the browser, we could come into this file. I guess it's in add candidate. And we could see that this is no longer correct and that we'll get some help and we'll know that cycle is correct. And even better, with the Viter implementation, you'll also see that live in your template. And hopefully, if this build succeeds, then we know that our app is once again ready to be deployed alongside that backend application. Yay! So that's what we've got. All right. I don't want to take too much more time. If people are interested, I'll talk very briefly about CI, but first, any questions about that? Yeah. Yeah, no, except for if you, what we've done on our end is we created utility scripts for when you update. Again, a lot of this is we get to piggyback off good architectural decisions from our backend team, but all of our deployments are tagged to a specific version, so it's 1.1.6 or whatever is the deployment, and our packages, which are generated on CI, have those same tags. So when we update, we don't just update the clients, we log out all the changes since the last one that you got. So that way we're encouraging people to know, like, these are the relevant changes. You can also, GitHub or Bitbucket make it really easy to link to show differences between two states in the repo history. So you're totally right. It wouldn't fail, which I would say is probably a good thing because you weren't attempting to use it. But in terms of being aware of it, yeah, it's something that we try to encourage devs to see as they're updating. That cool. Anyone else?
Yeah. Talk about how we test our test package.
Yeah, for sure. I'll cover that in the CI part, hopefully quickly, to not take up too much time.
I was thinking about that.
Yeah.
I think I missed it. I know it's a question. You're not checking in your.
So, yes here and no at work.
Okay.
Why don't we just jump into the? Yeah, no. Why don't we jump into this? Yeah, why don't we jump into the CI part real quick? So what you have here, and I'm sorry. Hopefully it's better. What we have here is code that's generated in the repository where you're using, and it's just there. And in order for it to work in order for your code to build when you run it through CI, for example, that code needs to exist there. So you could do kind of weird things about you could have it ignored locally, and then on CI you could generate it again. But this is what we started with when we only had one project doing this, because it wasn't worth doing anything. It was we only had one project, and it only used clients for 2 or 3 microservices, and so there was no real downside about checking in the generated code. And it was up to developers to say, okay, now it's probably a good time to update again. We'll see what the changes have been. But as we now have on the front end side, these are create markers.
I hope you hit the paper. It looks like you're above the paper.
What? No, this is the paper.
Okay.
Oh, sorry.
Oh my God. Honestly, from here, it does not look like that. I was like, oh my God.
All right.
I flew for himself after me. He's like, well, that's like good markers.
Fantastic markers. They were so well off. Our front end at Politico, we have, I guess it's 5 now, 5 Vue applications. And for backend microservices, we have, I want to say 7. Here it becomes really frustrating if you have to, for every Vue app, generate 2 or 3 clients and check those in and try to keep track of it, because by the time you update your 5th Vue app, you'll have checked in the same set of changes. So on the backend side, when a change goes through CI, so someone opens a pull request and we approve it, and it does something like it changes election year to cycle, then in Jenkins, but it would work just as well as in Bamboo or GitLab or whatever your CI pipeline is, we use the Open API generator. Sorry, this is small. We use the Open API generator, the same one that we had there, and we run it against the backend application. We just need the backend application to be generating its current Swagger specifications. So what we get there is a collection of TypeScript files. Then we take those TypeScript files and we package them in a @Politico API app. So it is a NPM package designed just for this one API. So one that we have is named Swag. So @Politico API Swag. And then this, still on CI, as long as everything works and it compiles correctly, then we publish. And I mentioned the thing about tags associated with deployments. The publish here is associated with the same Git tag as the deployment. So that means that we're able to see that for Swag, the most recent deployment perhaps, the most recent deployment was 0.1.55, and that is also the same version that we just published at NPM. And so we can know the next time that we install our API packages, we can know roughly which one, how many changes it's been since the most recent one that's deployed to our development environments. And then obviously the step over here for our Vue apps is just the next time that you need something new from the backend, you run, this uses the helper package, we just call it API publisher. And over here on the front end side, we have an API updater. And all that does is take a list of the applications that you're interested in. It sees if there have been any changes published since your most recent one, and then that's where it does the logging of the changes that you might be interested in that you didn't previously have, that you now have. And obviously the benefit here, or the thing that you solve, what you're installing is now a node module. It's not checked in. All that you're checking in is bumping. So that that's that. It's fun. It's a little bit complicated. It'll be documented a little bit in the repo as sort of a this could be an option, but I would heavily emphasize that our approach of checking in your client files, that approach, which is exactly what we looked at here, which is just when I'm in my Vue app, I run the generation and then I check those files in. We used that for 8 months and it worked fine. It was mildly frustrating once or twice. It's really only once you start to run into the problem of having lots of microservices that all need to manage their clients that it might be worth doing something CI related. I think that's everything. But how was that explanation-wise? I know that's a lot, but
Can I ask one follow-up?
please.
So you don't get that nice breakage on CI. You don't get that nice CI error until a developer checks in.
Yes. No, that's a great point. We've experimented with, or started to experiment with, what it would mean to run tests against sample Vue applications, for example, when someone's checking in their backend changes. So far, all that we've done is we've made sure that when this happens, we've made sure that the changes they make compile TypeScript-wise so that there are no errors, because that's been something we've run into with Spring Boot. But for now, we don't run any integration type tests, but it would be pretty manageable. You would probably check out, you would pick one of your Vue apps and check out when you'd install things with it. So, yeah, no problem. Any other questions? All right. Thank you very much for coming. Please let me know if you have any questions. I'll send the 2 repos, the slides, primarily those things. I'll send them in Discord and I'll tweet those out later this week. And I think that's it. Thanks so much for coming.